New technologies are pushing the boundaries of what's possible, rapidly replacing traditional methods. Advanced fighter jets, with their speed, precision, and unpredictability, are reshaping war strategies and becoming the keys to success in this new age. The X-44 nuclear anti-array at MANTA is a prime example of this next-generation weaponry. It is a game-changing technology designed to defy conventional limits, and it is sending shockwaves through global superpowers like Russia and China. How will the X-44 alter the future of warfare? What impact will this new jet have on global security and military dynamics? Join us as we explore how the United States' latest military innovation is setting the stage for a new era. The new technology in the X-44 has raised major concerns among global military powers, especially Russia and China. Even though these countries have made great progress in military technology, they now face a challenge that could change the balance of power in global security. The X-44 stands out because of its groundbreaking ability to fly in ways that regular aircraft cannot. By using anti-gravitational propulsion systems, it can travel through areas that traditional planes simply can't reach. This new technology changes the game, rendering old defense systems and countermeasures much less effective. To comprehend the significance of this advancement, imagine conventional aircraft as swimmers, constrained to move along the surface of an ocean, while the X-44 functions more like a submarine or advanced underwater vehicle, able to move through mediums and navigate spaces that were once thought impossible. Its anti-gravitational propulsion isn't just an incremental improvement, but a paradigm shift in mobility and strategic capabilities. Traditional defense systems and countermeasures have been meticulously developed based on predictable flight patterns and known aerodynamic principles. These systems rely on understanding an aircraft's potential trajectories, speed limitations, and physical constraints. The X-44 technology effectively renders these established defensive strategies obsolete by introducing unprecedented spatial navigation. The mechanisms that are designed to track planes following standard flight paths are critically vulnerable to the X-44's revolutionary maneuverability. Both Russian and Chinese military leaders have publicly voiced significant apprehension about how this technology could fundamentally undermine their established defense strategies in future military planning. Recognizing that conventional countermeasures may become obsolete against such an advanced aerospace platform, the X-44 was a secret aircraft design from the late 1990s, which stands for Multi-Axis No-Tail Aircraft. What made this design special is that it has no rear stabilizers, none of those vertical or horizontal surfaces that are normally seen at the back of planes. Instead, it controls its movement by changing the direction of its engine thrust. Think of it like this: regular planes use flaps on their tails to turn and point up or down. The X-44 would skip all that and just redirect where the engines were pushing. The design is not completely new. They based it on the F-22 Raptor fighter jet but stretched the wing into a triangle shape and got rid of all tail surfaces. In the wake of World War II, NASA and the Air Force launched an ambitious vision, a revolutionary aircraft unlike anything seen before. Engineers debated whether to test their innovative technologies on the sophisticated F-22 Raptor or the battle-proven F-115 fighter. Before advancing to a full X-44 prototype, with test flights targeted for 2007, the project aimed to develop America's aerospace legacy as quickly as possible. The engineers were not just interested in creating one experimental aircraft, they wanted to push the boundaries of flight technology. This ambition caught the attention of the government and contractors, who funded the initial research to see if the project could become a reality. In June 1999, the National Aeronautics and Space Administration, NASA, gave the green light to the project, officially naming the aircraft X-44A. However, by 2000, funding for the X-44 had dried up, and the program faced uncertainty. Despite this, the lessons learned from the MANTA project weren't lost. The innovations from the X-44 program influenced future aircraft designs, particularly the development of the F-22 Raptor. One of the key ideas that emerged from this experimental aircraft, CFT, was the removal of traditional tail fins, a concept that was later explored in FB-22 designs. The tail shape revealed crucial insights about radar signature reduction and aerodynamic efficiency, two elements that became fundamental to the F-22's blueprint. This shift established the foundation for next-generation encryption in high-performance aircraft, pointing toward a future where clean, minimalist designs deliver unprecedented maneuverability and radar evasion. The X-44's influence on stealth technology and aircraft design didn't stop there. It highlighted the potential for aircraft to rely on advanced propulsion and thrust vectoring instead of conventional flight controls. Although the project itself was cut short, its legacy lived on, pushing engineers to rethink traditional design principles and inspiring future innovations in the aerospace industry. Today's aircraft are not only faster, stealthier, and more agile, but they also represent the culmination of decades of research, design, and testing that began with projects like the anti-gravitational and passive detection avoidance features, like something from a sci-fi film. this jet uses a special coating called parallax that makes it hard to spot with radar or even the naked eye when flying at high speeds. Pilots rely on the same depth perception techniques that human eyes use to judge distance. A jet's targeting systems work by creating depth perception by comparing slightly different views. This helps pilots know exactly how far away enemy aircraft are. Therefore, as the MANTA moves, its computers compare the changing perspectives to build a 3D picture of the battlefield. This works just like how a pigeon bobs its head to understand depth. Modern jet HUDs, heads-up displays, also use a form of wiggle stereoscopy to help pilots see depth without looking away from the windshield. The display shifts slightly as the pilot moves, creating a 3D effect that makes targeting faster and more accurate. For years, the X-44 stayed secret, and many people thought it was just a rumor. But now, new information is coming out. Recent Pentagon leaks and actual sightings confirm the X-44 MANTA is real. What's more, the military continues to improve it for difficult combat missions. But there's more to it. The X-44 comes loaded with cutting-edge weapons. Its hypersonic missiles are rumored to hit targets with pinpoint accuracy within 16 feet. These missiles fly at 2,850 miles per hour, too fast for normal air defenses to track. This makes the aircraft nearly impossible to defeat in battle. The plane also carries precision bombs that stay on target even at high speeds, and it can hold lots of weapons at once. The payload capacity is substantial. Picture the aircraft zooming at 1,740 miles per hour, completely invisible to radar, as it crosses the battlefield. Insiders confirm that, even without weapons, the MANTA strikes like lightning, deadly to anything in its path. To control flight, the jet relies on thrust vectoring technology rather than traditional control surfaces. Its design eliminates the need for rudders and ailerons, using thrust direction instead to achieve precise movement. When decelerating, the aircraft adjusts its engine nozzles to increase drag and slow down efficiently, ensuring smooth control even at high speeds. In simpler terms, this is like steering a boat with a movable motor instead of a rudder. The jet changes direction by changing where its power goes. Not by using separate steering parts, the X-44 design is optimized for high-speed flight. Its sleek, streamlined shape follows the area rule, with the majority of the body positioned ahead of the wings, reducing drag at supersonic speeds. To maintain stealth, weapons are stored internally within the body, keeping them concealed from radar detection. It also features retractable landing gear and a tailhook for emergency landings, enhancing its versatility in various flight conditions. To stay safe, the aircraft has systems to put out fires and prevent fuel tank explosions. The engines sit close together at the back. They have rectangular nozzles that can tilt up or down by 20 degrees to help control the plane. These nozzles work with the flight controls and management system. Each engine has two separate digital control systems from Hamilton Standard and can produce up to 35,000 pounds of thrust each. The MANTA's power-to-weight ratio at normal fighting weight is almost 1:1 in standard power and 1.25 with afterburners on. Its fixed air intakes sit on the shoulders of the plane, offset from the front body to avoid turbulent air and create angled shock waves with their upper inside corners, which helps maintain good air pressure and efficient airflow at supersonic speeds. Without relying on external fuel tanks, the X-44 flies at supersonic speeds with afterburners engaged. It is designed with a large internal fuel capacity for extended range and mission flexibility, with the option for in-air refueling to support long-duration operations. The aircraft also includes a refueling connection and a backup power system for operational reliability in critical situations. The MANTA's encryption capabilities work through intelligent design rather than special materials. Unlike earlier stealth aircraft, it primarily deflects or absorbs radio waves through its shape and structure, rather than relying heavily on radar-absorbing materials. This engineering approach offers significant practical advantages. Traditional radar-absorbing materials require extensive maintenance and are vulnerable to environmental damage, creating operational challenges. In contrast, the MANTA can be serviced in standard facilities without specialized climate-controlled environments. Therefore, it incorporates an innovative self-diagnostic system that continuously monitors its observability effectiveness. This technology alerts pilots when any aspect of the system becomes compromised, providing real-time information about when maintenance is required and ensuring optimal performance throughout missions. As a small steel marble, the plane can also carry a special reflector to make itself more visible on radar when needed. When secrecy is required for missions, the plane is ready to go 62 to 70% of the time. The fighter jet's sophisticated defense systems provide the pilot with real-time threat detection and response capabilities. A network of 6 highly sensitive sensors creates an omnidirectional shield, scanning the entire surrounding airspace for potential heat signatures that might indicate incoming threats. These sensors act like vigilant electronic guardians, continuously monitoring the aircraft's environment. When the system detects an imminent threat, it instantly alerts the pilot and recommends precise countermeasure deployment. such as releasing infrared deflecting flares or radar jamming chaff to confuse and evade potential missile locks. This integrated defense architecture transforms the aircraft from a mere flying machine into an intelligent, adaptive system that can rapidly assess and neutralize potential dangers before they become critical threats. The seamless combination of sensor technology, strategic equipment placement, and rapid threat response mechanisms represents a quantum leap in aerial combat defense capabilities. Another interesting capability of the fighter jet is its ability to stay hidden from radio detection. The MANTA carefully controls its signals and only sends them in specific directions. When the pilots need to talk to each other, they use a direct data link. The communications system also handles identification, navigation, and various types of radio contact through different secure methods. The X-44 stands as an imposing aircraft, stretching 62 feet 1 inch in length, with a wingspan of 44 feet 6 inches. It reaches 16 feet 8 inches in height and features a wing area of 840 square feet, giving it an aspect ratio of 2.36. Pilots must develop an almost intuitive understanding of the aircraft's advanced technologies, transforming technical capabilities into strategic advantages during high-stakes combat scenarios. The training regimen for X-44 pilots is multifaceted and intensely demanding. Imagine a preparation process that combines advanced computer simulations with live flight exercises designed to push human cognitive and physical limits. These simulations replicate incredibly challenging combat scenarios, environments where split-second decisions can determine mission success or failure. Pilots must develop the capacity to process complex information rapidly, making strategic decisions under extreme psychological and physical stress. Their training would likely include psychological conditioning alongside technical instruction, preparing them to maintain peak performance in scenarios that would overwhelm less prepared operators. However, as artificial intelligence capabilities improve, it's possible that the fighter jet could integrate with autonomous systems for specific missions, allowing the aircraft to perform routine surveillance, reconnaissance, or strike missions with minimal human oversight. This would significantly reduce risk to human pilots, especially in dangerous combat zones. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there!